Hello, Math 140 students. We're going to pick up on page 6. So we're going to start with some vocabulary for our introduction to polynomials in section 5.2. So a blank is an expression that is a variable or a constant. It also is a one-term polynomial. It also has positive exponents on the variable. So that would be a monomial. So a monomial is a one-term polynomial. A blank is a numerical or constant factor in a term. Here we're going to say the coefficient. The blank relates to the exponent of the variables. Number 4. The degree of the monomial is the highest or biggest of the exponents of all the variables in a monomial. A blank is a monomial or a sum of monomials. So here I'm going to say a polynomial. And number 6, a polynomial containing two terms is a binomial. And a three-term polynomial is called a trinomial. You might be thinking, okay, why did I skip number 3? Number 3 isn't that important, so on the next round of notes, I will be editing that out. So let's look at these examples. We want to know whether or not something is a polynomial or not. So what you want to do to consider if something is a polynomial, you want to make sure that the exponent is positive and a whole number. So for number A, or for letter A, we have our exponent here. It's really a 1, so this is a polynomial. For letter B, we have our exponents that we're thinking about, and this is also going to be a polynomial. Now, for letter C, notice how this is a -6. So the fact that it's negative, we say not a polynomial. And here, even though it might appear to be a 1 over x, if we use your rules of exponents to rewrite this, well, I know that 1 over x is the same as x to the -1. So the fact that this is negative tells me that this is not a polynomial. And again, here, that 3/7, that's a fraction. So the exponent here is a fraction. So remember, it has to be a whole number, so this is also not a polynomial. Now we're going to have some practice problems. We want to indicate whether it's a monomial, binomial, trinomial, or has no special polynomial name. We want to identify the degree, and we also want to identify the leading coefficient of the polynomial. So let's think about this. Well, we know that polynomials, the terms are separated by addition and subtraction. So the addition and the subtraction, they separate the terms. So here I have 1 term, I have 2 terms, I have 3 terms, I have 4 terms. So I have 4 different terms here. So we know that we can figure out the exponent on each one. So this really has an exponent of 1. This has an exponent of 2, right? Here, we can think of this as an exponent of 0. And because I have 3 plus 1, my exponent here is going to be 4. So let's think about this. So whether it's a monomial, binomial, trinomial, well, I have 1, 2, 3, 4 terms. So I'm going to say it has no special polynomial name for part A. Now for part B, when I want to identify the degree of the polynomial, well, the biggest exponent here is going to be 4. So then my degree, I'm going to say, is 4. And for part C, to identify the leading coefficient, well, since this is the biggest, that leading coefficient here, even though you don't see it, is really a 1. So 1 is going to be that leading coefficient. So let's go ahead and look at number 2. Well, look at number 2, I can rewrite this. This is really 4m is equal to 3, not equals, but it's a subtraction. So 4m minus 3n to the negative 2. So the fact that this is a negative exponent, we have to be really careful. We know that a polynomial cannot have a negative exponent, so this is not a polynomial. So we can't tell you anything about that polynomial because it doesn't even classify as a polynomial. Now let's look at number 3. Let's think of all the terms here. We have 1, 2, 3, 4, 5 terms. So that is a lot of terms. So it has no special name here because there's too many to count. Now I want to think about the degree. So we want to look at the biggest exponents, okay? So here it looks like I have an exponent of 6. Here I have an exponent of 2. And now I'm going to have to add these together. So if I have 5 plus 3, that gives me an exponent of 8. This is 1 plus 3, so that gives me an exponent of 4. And this is really an exponent of 0. So the biggest number that I have here is 8. So my degree is going to be 8. So since that degree is 8, then that means that this is going to be the leading coefficient because it has the biggest exponent or the highest exponent. So that leading coefficient here, that number there, is a negative 3. The next example, it says to combine like terms and write the resulting polynomial in descending order. So you want to go from biggest to smallest. So I'm going to combine the x3's here. So I have 10x3 minus 3x3. And now I'm going to look at my x squares. So I have a negative 4x squared and a negative 5x squared. I also have a positive 6x. And I also have just regular numbers that don't have any coefficient. So I have a positive 8 and a minus 9. So now I'm going to add these together. So I'm going to have a 10 minus 3, which is going to give me a 7x to the third power. I'm going to have a negative 4 minus 5, which is a negative 9x squared. I also have a positive 6x that did not combine with anybody, and 8 minus 9 is going to give me a negative 1. So that is how I combined and wrote my order in descending order. Now we have some practice problems. So we want to combine like terms and write the resulting polynomial in descending order. So since these are practice problems, this is where I'm going to challenge you guys to kind of do the work on your own. So I'm going to press pause, and I also want you, the student, to also press pause and work out these problems for practice problems. So go ahead on your computer, press pause, and work out these problems. Okay, so I hope you guys really worked out those practice problems. So for number 1, I combine my a, so that's a negative 4, and then I have a plus 5. For number 2, what I ended up doing is I kind of color-coded because there was a lot going on. So I first looked at my b to the 5, combined those to get me negative 21. Then I looked at my blue, which is then I looked at my yellow, which is that v to the 3. So 12, negative 5, and positive 1 gives me 8. Then I looked at v squared, which is the 19 and the 16, to give me 35. And then that negative 22 didn't combine with anybody else. And for number 3, what I ended up doing is I kind of just regrouped them because they're fractions. So I put my a squares together in yellow, and then I put my a's together in green, and then I just used my calculator to help me do the fractions. And that's going to be my final answer there. So you get that 7, 6a squared minus 19 over 15 over a. And that is the end of the section. If you guys have any questions, please feel free to contact the Math Success Center. Thank you.